Hey, and welcome to another lesson video. This time we're learning about evaluating radicals, and that's exactly what our learning target is. So when I say radical, let's make sure that you understand the parts, the pieces and parts of a radical expression. So obviously you have the square root house. A radical symbol is its official name. This little number is the index, so that tells you what root. If you're doing the square root, cube root, fourth root, whatever, depends on this little index. What's underneath the radical symbol is called the radicand. So that way you're familiar with some of the terminology I'll be using. But the index, it's a pretty cool little guy. And there's some special rules that we need to know about him. First of all, if you look to the left of your screen, there's the square root of 16. Now, notice there's no little index there. So the rule is when there's no number, it's understood to be a 2. Okay? Now, what is the square root of 16? I think I'll show you the normal way of simplifying. Think of a factor tree. Okay? Factors of 16, pick any pair. I'm going to go with 2 and 8. Keep breaking down this 8 to 2 and 4. Keep breaking down the 4, 2 and 2. Now this little index tells me that I need 2 pairs of a number, and then that will let me take that number outside. Okay, so I need a pair, so I need 2 of a number to be able to take it outside. So here is a pair of 2's. Okay, so what that means is outside of the radical symbol, a 2 will get to come out. It takes 2 for 1 to come out and play. And then I have another pair of 2's. So with this 2 that's already out, well, by golly, another 2 is going to come out with it. Now, do I have anything left? Some people try to say, well, you have a 4 left or an 8. But you kept factoring those numbers, so technically you've already used them. So there's nothing left. So my radical symbol, I don't need it, okay? There's nothing to put back under it. So I just need to know what is 2 times 2, which is 4. All right, so the square root of 16 is 4. Now you might have known that just through memorization, but I wanted to give you an illustration. So let's look at this cube root. The cube root of 27. Okay, do a factor tree again, 3 and 9. Keep breaking down your 9, 3 and 3. Now, over here, I needed a pair of numbers. I needed 2 of a number to take it out. This time, because the index is a 3, I need triplets of a number. I need 3 of them. So there's 1, 2, there's 3 3's. So I have just enough to take a single 3 outside. Now again, there's nothing left. Remember the 9 broke up and we already used its parts. So there's nothing left to put under that cube root house, so I don't need it. And the cube root of 27 is simply 3. Now this might seem easy enough and, you know, why am I showing you all of this? We already know this, Miss Weaver. But what about when you have negatives? Here's where the rules really come into play, okay? Like we said earlier, when there's no index, it's 2. Now, what about when you have a negative number under your radical symbol, in particular this square root house? Here's the rule with negative numbers under the house. If it's an even index, so like a square root has an index of 2, so an even index means you can't do it. There's no solution. So the square root of negative 16, because that 2 is even and there's a negative under that radical house, I can't do it. There's no solution. Now, let me tell you why. Obviously, we know 4 times 4 is 16. All right, I need my numbers to multiply to a negative 16. So my options are to have them both positive 4 or to have them both negative 4. But still, this product, when they're both negatives, that still equals a positive 16. I'm never going to be able to get a negative number when I have an even number of those numbers, if that makes sense. So I have an even number of negative 4's, so I'm never going to be able to get to negative 16. So that's why we say it has no solution. Now the other rule, when you have an odd number, you're actually able to do it. So odd index implies that you can do it. You can do it. Sorry, my computer, it's just like Gretchen in class. She's really slow for some reason. So let me fix that because that was sloppy. You can do it. So over here, on our previous slide, we knew that 3 times 3 times 3 equals 27. Well, if I make them all negative, I will in turn get the product, negative 27. So the answer to the cube root of negative 27 is negative 3, because I can take 3 of them based on the index. I need 3 of them. I can take 3 negative 3's and they will multiply to negative 27, the radicand. Okay, so remember, even it's not possible with a negative. Odd, it is possible with a negative. So let's look at some more practice real quick. Square root of 144. You know, you can do a factor tree, but I picked some pretty simple ones that I'm just going to go with on my head. Remember, this is an even 2. I don't have a negative, so you know, this is just normal. So this is just going to be 12. You could do a factor tree, and you should end up with a 12. No radical symbol though, because there would be nothing left to put under. Here, oop, I see a negative, so we better check our rules. Check the index. Can I even do this, or am I not allowed? Because it's odd, I'm going to give it a green check mark. That means we can do it. Our previous slide tells us we can. So, if you want a factor tree of 125 to help you figure out the number, you could. So you can see that it's going to take us 3 5s to get 125. But what about their sign? I need it to be a negative. This multiplies to a positive. Well, make them all negative 5s, and since you have an odd number of negatives, you will indeed multiply to negative 25, so your answer is negative 5. All right, here we go. Here's another one. Oh, there's another negative sign in there, but oh, there's an index of 4. What's that mean? Well, that's even, so what are we gonna say? Are we gonna give it a green check mark? Oh, no, an even index and a negative number underneath, that ain't happening, bro. So that's no solution. You can't even do it, so don't waste your time. Now, I hope when you're looking at this next one, ooh, you're freaking out a little bit because there's that decimal, but it's okay. This is actually a really cool problem. Here's the trick to it. 0.001, think back like way elementary school where you learned place values. This is the tenths, hundredths, thousandths. So what that decimal is telling you, you have 1/1000th if you put it in fraction form. Now, a cool thing that you should have learned last year in Algebra 2, with radicals with a fraction underneath, you can actually split it up. Make it a cube root on the top and a cube root on the bottom. Okay? Now, the cube root of 1, any root of 1, second root, fourth root, whatever it is, equals 1. Now, what is the cube root of 1,000 though? Well, if you need to do a factor tree, we could do that real quick. So I'm going to go with the pair 10 and 100 that multiply to 1,000. And then that 10, that 100, I'm going to break up to 10 and 10. So I've got, check it out, yo. I got 1, 2, oh, I got trace 10s. I got 3 10s, which is exactly what I need based on the index of 3. So that means a 10 will come out. And oh my gosh, look, there's my answer. The cube root of 1/1000th is just 1/10. Awesome, cool beans, that's so cool. Hopefully you're as excited as I am. I know you're probably not. But anyway, that concludes our video on evaluating radicals. Remember, that was our learning target. Here are the preview problems. Please make sure that you don't write your answer in decimal form. So don't just use your calculator and think that's going to work. I need to see the work to give you credit for your preview problems. I will be checking these at the beginning of class. Have fun and keep learning, guys.